Hi, I'm Sam Reed, and this is Team Ready to Graduate's final product presentation.
I'm Graham Kowalski, fellow development team member.
I'm the product owner, Eric Robeck.
I'm the Scrum Master, Tyler Payne.
So for our product vision, our final vision statement is for GIS professionals who need to display georeferenced imagery in Earth browsers such as Google Earth and ArcGIS Earth. Raster KML is a Python script tool that produces high-quality ground overlay KMZ files. Unlike the built-in ArcGIS Pro layer to KML tool, the Raster KML tool exports imagery without decreasing positional accuracy, degrading image quality, or distorting aspect ratio. So the rationale of our project is to improve upon ArcGIS layer to KML tool. This built-in ArcGIS Pro tool doesn't work well with raster datasets, as we'll show later in the presentation. And so to build a new tool, we set out to build a new tool that is superior to ArcGIS's built-in tool. And in terms of project management, we used agile practices and methodology. All of our product requirements are broken down into 21 distinct user stories. These user stories were implemented across 3 different releases, each release being comprised of 2 sprints, which were 7 days in length. As you can see from the burn down chart to the right, taken from our product backlog, we mostly stayed on track to implement these user stories over the course of the 6 sprints. And we did this accommodating for the need to work remotely by holding weekly meetings via Zoom and troubleshooting and sharing code through Slack. Obviously, we ran into certain difficulties with this, especially with Zoom, given the 40-minute time limit to meetings. But other than this, the process of working remotely mostly went pretty seamlessly.
So as Sam mentioned earlier, one of the primary motivators to create our new tool is the existing layer to KML tool in ArcGIS Pro. So to briefly touch on some of the defaults of the existing tool, it's designed for more vector feature conversion. Pixels are resampled into WGS84 without the ability to select a CRS of the user's choosing. So this means at higher latitudes, the image is distorted heavily. Notably, the extent properties selector does not work, and all images are downsampled to 1024 pixels on the longest side. Additionally, perhaps most annoyingly, it adds a thick transparent buffer around any resampled imagery that reduces overall image quality, especially considering that the longest length is 1024. To touch on the image output properties, the final selector down at the bottom of the tool, the options are confusing. The size of the returned image in pixels doesn't say whether it's rows, columns, max height, or max width. No matter what values are entered for the size of the returned image or the DPI of the output image always has a max width or height of 1024. And dots per inch of the output image doesn't make sense for georeferenced imagery. Is it georeferenced in CRS inches? Probably not. And it wouldn't make sense to measure the image in inches anyway, since it will not be hosted on any website or printed.
So another issue we had with Esri's layer to KML tool was that it lacks any kind of useful pop-up bubble description. It only contains the source layer name, which it uses for both the name and description of the bubble, and that's all the bubble has. It contains no additional metadata, no information about the source, and no image dimensions or anything like that, as you can see in our example here at the bottom right. And on the right side of that, you'll see how our tool aims to correct that and an example of what our KML bubble will look like. And then here we have both ArcGIS Pro's Layer to KML image output and then our image output. As you can see on the left, Esri's output provides a very stretched image with no rotation. It creates a bunch of null pixel values for the margins. And again, as Graham mentioned earlier, it only allows for up to 1024 pixels in maximum length or width. Where our tool, we can adjust length or width, we can adjust aspect ratio. It adjusts for rotation, so you won't have this extremely stretched image. And there's no null pixel values in the margin. And then I'm going to pass it on to Eric, who's going to talk to you about the our tools features.
Yeah, like Graham and Tyler mentioned, our tool does pick up and improve upon a number of the Esri disadvantages. So, for example, our tool allows the raster resolution to be defined dynamically using either the resolution, rows, or columns. And by doing this, it exports the image with the correct aspect ratio. Rows and columns are kept within the aspect ratio of the original image, like you see down at the bottom. Also, there are no transparent pixels because we use the rotation factor to actually align the image in a way that no transparent pixels are needed. And we allow the users to use either nearest neighbor, bilinear, cubic, or majority in case they have categorical data or they want to resample fine images like satellite images, which are best used with bilinear interpolation. So that's our current presentation. Now I'd like to give you a brief demo of the project. This is the catalog with our tool, raster to KML, and the Python script is called raster to KML ground overlay. By opening that, you can see a number of things. We have groups at the bottom with the KML raster information and the source raster information. This is used as a reference to control the resolution and the rows and columns of the output image. So I'll show you how that works. We can go into here, and if we have a image in the map, we can copy that over here, and it automatically updates the raster resolution. It creates an output file. They default to the same source image folder, and it creates a KMZ file, which is a compressed or zipped KML file that stores both the image and the KML that references it. Again, you can choose the ground overlay format that you want. Even if the source image is a TIFF, you can export it as a JPEG or PNG to reduce file size for sharing or transferring on the internet. And like I mentioned earlier, you can choose any of the Esri supported resampling techniques. If you have categorical data, you don't want to change the image values, you can use nearest or majority. If you have imagery or continuous data sets like elevation rasters, you can use bilinear or cubic to get a smoother surface. And also, our tool supports either using the source projection, which can be UTM in many cases, or you can project it to WDS84 like Esri does, only in this case it's optional. But by keeping it in the source projection, this allows you to use rotation to align the image better on the screen or on the map and not have to include any void or black pixels. So the first thing that happens when you choose your raster data set, it extracts the raster resolution and the rows and columns of the data set, the pixel dimensions. And then it uses an optimal raster dimension for KMLs, because these are supposed to be lightweight images that you can just pop into a Google Earth or ArcGIS Earth. They're not designed to hold megabyte or hundreds of megabytes of files. So if the file is really large, it's best to downsample it to something less than 1600 rows or columns. And you can do that by inputting any number you want. Oops, so if I, for example, wanted to use 10 meter resolution, then it would downsample that to 150 by 150. Or if I wanted to say, let's make it 500 by 500, it'll automatically update the resolution to keep those in sync. That prevents any stretching or exaggeration. Okay, so let's choose a 3 meter resolution. Actually, I take that back. Let's choose 1 meter resolution. So that downsamples it to 1500 by 1500. Now I'm going to hit run, and when the process completes momentarily, you can see the details. Here's the product that you get and how it was generated. Now we can go to our project folder. Here's the KMZ that we created. So I will open up Google Earth, and what we'll do here is open this new image, and you can see that it overlays very nicely on the satellite imagery base map. As you zoom in and toggle these, you can see that they match very well, and the resolution is quite high, considering this is 1 meter data. So there's not much difference in quality between the Google Earth map and the data set that we just imported at that resolution.